Hello, my dear students. A warm welcome to all of you in today's lecture. And in today's lecture, we will be dealing with electrostatics. In electrostatics, we have done Coulomb's law and what are the charges, what are type of charges, what is static electricity, what is the vector form of Coulomb's law. Okay, today we will be dealing with properties of electric charge. Okay, there are three basic properties of electric charge. First is additive nature of electric charge, then quantization of electric charge, and third is conservation of electric charge. Right? So, first is additive nature. What is additive nature mean? Let us suppose there are more than 2 to 3 charges in a system. Say there is one charge Q1, there is another charge Q2, there is another charge minus Q3, there is another charge plus Q4, there is another charge minus Q5. Okay, so in this system there are total 5 charges. Then additive nature of charges says that we can add these charges. Okay, so likewise in a case of a body where there are different mass points are there, we can add these masses, so the total mass of the body is the algebraic sum of all mass points. Similarly, when we talk about additive nature of electric charge, so electric charge can be algebraically added. Algebraically mean taking into consideration the positive or negative sign of the charge, because there are two types of charges, positive charge and negative charge. So the total charge on the system is say Q, it will be written as Q1 plus Q2 minus Q3 plus Q4 minus Q5 and so on if there are more charges. So it means charges can be added in a system. Okay, this is the meaning of additive nature of charge. And the total charge on a system is the algebraic sum of all the charges. When we say algebraic means we have to take positive sign and negative sign also into consideration. Okay. Then the second one is quantization. Now to understand quantization, let us understand a word quantum. What is quantum? Okay, quantum is the minimum amount by which a physical quantity can change. I will give you some simple example. Have you seen a building, like construction of a building in your neighborhood? You might have seen that there are some buildings which are going on, the construction is going on in your neighborhood area or at any other area where you might have seen that they first make foundation, okay, then they make ground floor or basement, then ground floor or stilt parking, then ground floor, first floor, second floor, third floor, and so on. Right? Is that okay? But have you heard of this type of floor? 2, 3 by 4th floor. Have you heard this term? No, never. Because it is not possible. So it means the floor can have only a fixed discrete value. Discrete means a fixed value like 0th floor, first floor, second floor, third floor, fourth floor, and so on. But you cannot say that it is 2.8 floor. Not possible. Similarly, here the word quantum comes. The minimum quantity by which, the minimum amount by which a physical quantity can change, like 1, 1, 1. This is the minimum quantity. Similar is in the case of charge. The minimum quantity or quantum in that charge is always taken as E. This E is the charge on electron and its value is 1.6 10 to the power minus 19 coulomb. Naturally, charge on electron is negative and charge on proton is positive. Okay? On proton, it is positive charge. Basically, it is negative. And if you take proton, it is 1.6 10 to the power minus 19 coulomb. But it is having a positive sign. And electron charge is having a negative sign. Right? So, it is the minimum amount by which charge can have value. The charge cannot be continuous actually. It is a kind of discrete system. Like in the building, you saw that there is ground floor, first floor, second floor, third floor, and fourth floor, and so on. They cannot have the continuous value like 2.1, 2.2, 2.3, and so on. No, it's not possible. In the similar way, when you talk about quantization of charge, so quantization of charge means electric charge can have discrete value. They cannot have continuous values. Okay, they can have discrete values, and that quantization of charge says that the total charge is given by n times E. Now this E is nothing but charge on electron. Okay, and this n can have value 0, plus minus 1, plus minus 2, plus minus 3, and so on. Okay, what is Q? This is the total charge. N is an integer having values this. It can have value 0, plus minus 1, plus minus 2, plus minus 3, and so on. And E is nothing but charge on electron. Right? So it means when you talk about quantization, the quantization words come from quantum. And what is quantum? Quantum means the minimum amount by which any physical quantity can change. Here quantum is this much. The minimum amount by which charge can change. It is 1e, then 2e, 3e, 4e, and so on. It cannot be 1.5e, not possible. Right? Mean it can have only discrete value, not the continuous values. Okay? So this is called quantization of charge, and this formula is very important if you want to study numerical problems on this, right? Now the third one is conservation of charge, and before going to conservation of charge, do we have a cause for quantization? Mean the charges can have discrete values only, not the continuous values. Do we have a cause for it? Yes. Static electricity is the cause. When we rub glass rod on silk, if you remember in my previous lectures, you saw that there is a transfer of electrons. Transfer of electron from glass to silk. It means, or silk to glass. What does happen? What actually happens? There is a transfer of charge. Okay, electron is transferred from one body to another. But these electrons are transferred in discrete values, 2 electron, 3 electron, 4 electron, not 2.5 electrons. It is not possible. That is why this is the cause of quantization. Only discrete values can get transferred. That is why charge is always quantized. It have a quantified value, mean only discrete set of values, 1, 2, 3, 4, and so on. Like 1e, E mean electron or charge, 2e, 3e, and so on. Then comes conservation of charge. What is conservation of charge? Conservation of charge simply says that if there is an isolated system, what is an isolated system? Isolated system is one on which there is no effect of all other factors. Like it is a closed one. Like if we imagine a box in which there is no effect of outer parameters, temperature, pressure, or any type of parameter on that box, no other forces are acting upon that box, then that closed system is called a system in which it is isolated one. Like it is having a kind of separation from the outer world. Okay, so in isolated system, conservation of charge says that the total charge of the system remains constant, provided it is an isolated system. Always remember. Okay, and the second point of this is that charge can neither be created nor be destroyed. It's like energy. Energy can neither be created nor be destroyed. The total charge of the universe always remains constant. This is the beauty of universe. If the total charge remains constant, you can explain with this different type of phenomena like Big Bang. You have heard about Big Bang. What was Big Bang? The theory of universe, theory of evolution of universe was explained on the basis of Big Bang. And somewhere in quantum realm, in the quantum mechanics, it was somewhere used like charges. The system should be isolated one, then the system is having total charge constant. Similarly, in the case of universe, total charge of the universe is always constant. There are a lot of researches going on this, how the universe was created. Only we have, 5 to 10% of experimental data and theoretical data. Still the research is going on. How the universe was made. Is there any other physics, other dimension which could affect the evolution of universe, or the charges of the universe are constant? What we are saying is true or not. Also, the research is going on this topic also. Okay, so conservation of charge simply means total charge in the universe always remains constant. Total charge in an isolated system always remains constant. Charge can neither be created nor be destroyed. Very simple. Okay, we can give the examples. Okay, like we have one example, say ionization of salt NaCl, and NaCl breaks into Na plus and Cl minus. The total charge before the ionization and after the ionization are same. Okay, so this is one example where you can see the charge is conserved. There is another phenomena which you might have heard in your daily life also, like when we rub a glass rod or a comb in our dry hair, then the charges are transferred, like it is a comb and these are dry hair. So when we rub comb on dry hair, some charges are transferred here. So it means, say, 2 electrons comes out of this. So it requires 2 electrons. It means plus 2 positive charge is there and minus 2 charge is there. It means total charge of the system is again 0. No problem, right? Like it is 2 minus 2, 0. So it means charge is constant. It is not actually created. You have just transferred. Okay. Another example of this is when an electron and a positron. What is a positron? Positron, positive electron. Mean charge is same, but it is positive electron, right? So minus E minus and E plus are the symbols. This is a symbol of electron. This is a symbol of positron, positive electron. When they combined, they give gamma ray. A gamma ray is having no charge. So before reaction, plus minus 0, gamma ray has no charge, so 0, 0. So it means charge is conserved. Here this is one example. Okay, and then another example is the nuclear reaction, nuclear fission. When an electron combines with uranium, it dissociates into krypton and barium, and plus 3 neutrons are released, plus huge amount of energy is released. This is the nuclear fission reaction. In this reaction, you can see that this charge, total charge before reaction is 92 and here is 56 and 36. When you combine this, it is 92. So before nuclear fission, it is 92. After nuclear fission, charge is 92. So charge is conserved. There are a lot more examples you can see in your daily life. So these are the three properties of electric charge, which states that charge is additive, means charges, electric charges can be added. Okay. Second is quantization, means charge can have only discrete values. It cannot have a continuous value. Can you give example of some phenomena where this quantization of charge fails, where we say that charge is not discrete, it is continuous? Yes, one example is there. When we are dealing with macroscopic objects. What are macroscopic? Two type of objects are there in our whole life. One is microscopic, mean which cannot be seen with the eye, very very small, and macroscopic mean big. Like if you have a 100-watt bulb and you give that bulb current, okay, then you see that when you're giving current, the bulb will glow. Now in 1 second from this source, 2 into 10 to the power 18 electrons, 2 into 10 to the power 18, this much electrons passes through this filament, okay, and the filament glows. If the charges are discrete, if the electrons are discrete according to quantization in this bulb, then this bulb should glow like this. It should flicker. Mean once it should be off, then on, off, on, off, on, because it is having discrete value according to quantization. So quantization is not applicable when the objects are macroscopic. Then we say that there is continuous electron supply, like it is going continuously. Okay, so quantization of charge is possible only for microscopic world, when 2, 3, 4, 10 electrons like these are transferred. When large number of electrons are transferred for a macroscopic object like bulb, then you say that it is continuous charge which is flowing through the bulb. Because if it is not continuous charge, it is discrete charge, 1 electron, 2 electron, 3 electron, then the bulb, when first electron comes, bulb should glow, and during the first and second electron it should switch off, and when second electron reaches it should glow. So it means if the charges are quantized, bulb should flicker, mean it should like jalna bujhna chahiye, it should like on and off, on and off, but it is not so. It means in this case charges are not quantized, charges are continuously flowing. That is why we say that quantization of charge is not applicable to macroscopic objects. Okay. Third one is conservation of charge. So conservation of charge means when we say that there is an isolated system which is having no effect of outer world or outer atmosphere, then it is isolated system, and in an isolated system total charge is constant, and charge can neither be created nor be destroyed. I gave you so many examples where you can see that the total charge before reaction and after reactions are conserved, constant, they do not change at all. Only transfer of charge is there, right? So this was all about the properties of electric charge. And please, you are again requested to subscribe to my channel if you are new, and you can share to your friends also so that knowledge can flow. Thank you very much.